I'm Anil Kumar, and in this video we'll try to understand how to represent complex number and their scalar multiples, right? So we'll have a coordinate plane in which the horizontal axis will represent real numbers and the vertical axis will represent the imaginary numbers, right? So we say this represents the real numbers, right? And this represents the imaginary numbers. Okay. Now the question here is to represent scalar multiple of complex numbers on a rectangular coordinate plane. So let me begin with the I itself. So we'll take example as I itself. So what is I? I could be represented like this, 1 unit along the imaginary part, right? So that is I for us. Is that okay? So this is I. Okay. So if I want to represent 2 times I, how can I do that? That's a scalar multiple. Just multiply 2 times, so you get it twice the length, so it becomes 2i. So this length here represents 2i. Is it okay? So if I'm saying that this is my 0, then the point A, OA I should say, represents, let me draw with an arrow, I, and the point B along this vertical axis represents 2i. Do you see that? Okay. If I have to represent, let us say, minus 3i, it basically means this is my I. I'll just multiply by minus 3. So this vertical line going downwards, let's say this point is C, where this is minus 3, OC will represent minus 3i, correct? So these are also complex numbers where the real part is 0. So if the real part is 0, the complex number will be along the vertical real axis. Is that okay? Now let's take up examples where we have both complex and the real part. So to keep it very simple, what I will do is I'll write a number which is, let us say the number is 2 along the real side plus let's say 3i. Okay, let's say I, just say I, okay. 2 plus I. So 2 plus I really means that along the real part, let's say this is 1, 2, okay. So 2 is along the real part, this is 1, this is 2. And the complex part is I, so 1 unit up, right? So 1 unit up. So this becomes here, let's say this point is P for us. Then OP represents 2i. We could actually write this also in the coordinate form, right? We could write this as 2, 1. Is it okay? 2, 1. Now, if I multiply this by, let's say, number 2. If I say 2 times 2 plus I, now what does that mean? That means it's a scalar multiple of this vector. So I just extend it by the same length along the same side, right? So basically what happens here is that 2 gets multiplied with the numbers inside. So it is basically 2 times 2 comma 1, 2i, or you could write this as 4 comma 2. Do you see that? Both are same. So this point will be represented by the horizontal line, which will be at 2, and the vertical line, which will be at the real part of 4. Is it okay? So this will be, think it is 4. Okay. So that line, let me say Q, will represent 2 times 2 plus I. So OQ for us is 2 times the vector, complex number 2 plus I. So it's very similar to what you did in vectors in a way. So the coordinates could be written as, for OP, real part is 2 for OP, right? And the imaginary part is 1. For OQ it is 2 times 4, 2. Do you see that? So that is how you could represent scalar multiples. Let me also show what will this be if I write this as 3 times 2 plus I, but 3 is negative. If 3 is negative, then it should tilt this side. Is that okay? So what really happens here is, let's say we want to represent by OR. Then the coordinates OP, which is 2 and 3, will get multiplied by -3. -3 times 2 is -6, and -3 times 1 is -3. So we'll get a point which is on this side, -6, kind of like this. 1, 2, 3, 4, 5, 6. That is -6, and then -3 is kind of here, right? So a line from O to this point, let's say this point, which is R for us, and the coordinates for R are -6, -3. This line represents -6 minus 3i. Do you see that? Which is OR. So scalar multiples are basically, if you have a complex number, we can extend along the same line, and the magnitude doubles or triples as that scalar number is. So that is how you could represent a scalar multiple on a plane where one of the x's is real numbers, the other one is a complex number, right? These diagrams which I am drawing here are also called as Argand diagram, okay? So we'll see more of this, we'll practice with some more questions so that we become familiar of representing the complex numbers graphically. I'm Anil Kumar, and I hope that helps. Thank you and all the best.